What we've got here is a project started by one of our former compiler engineers, Richard Osborne, which is a full version of Doom. And the interesting thing about this is it's not just running the actual game, it's how you get all the sound and audio out on the board so you can make it a playable game. So, in the original game, you had PCM samples, which are the sound effects. That's relatively straightforward, but then you also have MIDI, and a really big part of Doom is the background music. It really created the atmosphere and the environment, so it's something I desperately wanted to get going. So what we did was use a number of the hardware threads on the XCORE.AI, made things like a MIDI sequencer, which takes the instructions of notes and then turns those into something that a synthesizer can then create, and then mix in with all the PCM samples, and XCORE is pretty natural audio. And on this board we've got a DAC, so we run that and then basically play all the sounds straight out the 3.5 audio jack. The original game runs at 320 by 200 pixels, so it's just a little bit under quarter VGA. And with the addition of a very cheap 3-inch colour LCD, we can drive video frames. So that's running a 50 MHz SPI interface with just single bit data. And so that can support up to 40 frames per second. And the original game was capped, I think, about 35 frames per second, so that is fast enough. Video buffer is about 120 kilobytes or so, it's 320 to 40, 16-bit colour. And what we do, we take the output from the game engine, and then we do a lookup table to turn it from a palette plus a 256 level colour into a 16-bit colour. And that's all done on the 2 threads on the XCORE. The original game typically ran something like a 486 PC with 4 megabytes of RAM with a hard disk available. Now the actual game storage is what's called a WAD file, and that's about 4.5 megabytes. That's too big to fit on chips, so what we do, we put that in the flash and running inside on one of the thread flash file systems, so it enables effectively very fast file accesses to read all the game data, which it does during the game operation. The original game, of course, came from the 486 era of PCs where a single thread was all you had. So the game itself runs in a single thread on our chip. So we're giving it approximately 160 MIPS, and that gets us certainly 30, if not capping out at 35 frames per second, which is pretty cool considering this is a few dollar chip.